If you scroll down to the bottom of the assignments page, you'll see three things that say optional. This one says Swing Graphical User Interfaces. It's using NetBeans Form Designer to create graphical user interfaces. So they're tutorials from my last time I taught Advanced Java, last semester. There's actually two videos there. You'll want to watch both videos. And then there's a little file full of code snippets as well. And then there's one called Web and File Operating System Access, and then one called Threads in Java. Now I actually want to hit all of this stuff, but we only have 3 classes left. So it could be that we're not going to do one of these topics justice. So I'm putting them out there anyways, so that you can do them, you can look at them, you know, get extra credit for doing them. So I know that some of y'all are real good about watching the videos, you know, and you'll even search out videos for other classes, you know, that I've taught. Watch them on your own time. If you're that type, you might get a lot out of these things. Really hoping that we do these 2 things, even if we have to do these 2 things in a single day. But if we're doing them in a single lecture, we won't do them as much, you know, as we do here. So I just kind of took those down there. Hopefully we'll get to cover most of that material anyways. So what are we doing today? Files and exceptions. We've already done exceptions a little bit.
Saving to and from.
Pardon me?
Saving to and reading from.
Right. And a couple of different mechanisms for doing that. And then the book shows a couple of other mechanisms that we're going to give short shrift to. But they're worth at least mentioning, and it's certainly worth reading, right? You know, always read the book.
Can I ask you a quick off-topic?
Oh, please do.
What is the difference between FX and normal Java?
FX?
Java FX and normal Java.
Well, I don't know. Let's find out.
The only reason I'm asking is because when I use Swing and I drag and drop things to the panel, it displaces everything else. I don't know if that's just me or if that's like a Swing thing.
Yeah, and you can...
And I don't know
The form designer in Swing is kind of annoying, but it's way better than creating them by hand. Okay, so Javafx, software platform for creating and delivering desktop applications. That sounds real cool. Looks like something I need to learn so I can pass it on. Before version 2, developers use a statically typed declarative language called Javafx script to build the applications. So it's a replacement for Swing. Maybe it's a better one. I don't know. Swing is kind of annoying, but I've done all my user interface development in the past with Swing.
Can I use this for the final project?
Yeah, sure. That'd be cool. Pretty much anything you developed in JavaFX would be a cool project because it's not something I'm teaching, so you're having to do external learning in order to get it done. So that would be cool. All right, so we did a sample of exception handling. So I don't think we're going to have to talk about it too much. With exceptions, you enclose the code, the problematic code that can throw exceptions, and then you have one or more catch statements underneath it. And in general, you want to catch every type of exception that this code can generate, right? Some kind of classes, some kind of things can throw more than one exception. You have to go and look at the API to figure out what your code can throw. We've been doing the simple examples of divide by 0 and numeric format. You know, if you try to parse some data, or you use, you know, the scanner and you read in something and they typed in the wrong kind of data, those throw specific exceptions that we play with catching. So here is a fragment. Try, and then we're parsing the int. If it fails, we catch the number format exception, and then we print invalid quantity entered. Now, if you're feeling brave, or if you're feeling this is actually cheap and sleazy, and I wouldn't do it, you can just catch all exceptions that code could throw in one thing. But that's bad because you don't know how to differentiate it, right? You can't tell the user what went wrong. stuff like that. For something like parsing, right, there's really only one thing that could go wrong. And, but the larger the block of code that you're putting in the try catch, that's really nasty. Instead, you want to go ahead and list catches for all the different types of exceptions that it can throw. Now, certain kind of exceptions have to be caught. The code won't compile. Other exceptions don't have to be caught. Number format exception doesn't have to be caught. It'd be annoying if every time you called a parse function, you had to enclose it in a try catch. Divide by zero is another one. It'd be annoying if every time you use the division operator, you had to close that in a try catch. Those are called unchecked exceptions. Checked exceptions are the ones you absolutely have to catch. And all of the I/O, all of the, input-output stuff, whether it's communicating over the network or saving to a file or something like that, the exceptions are checked because it is so fraught with error, saving to a file or accessing over the internet, so fraught with peril that you have to be able to handle the things. The internet might be down, you might have a bad file name, the file may be locked, you may be accessing a path that's, doesn't exist, the file may be full, all of that kind of stuff. If you're talking on the network and then the network goes down in the middle of that, all of that stuff needs to be caught. So those are checked exceptions. There's a keyword that this isn't showing called the finally keyword. Finally is stuff that has to be done regardless of whether there was an exception or not. If the code completed without being tossed into the catch section, it still executes the finally section. If the code does catch an exception, it still executes the finally exception, the finally clause. So in this case here, after we try parsing, we catch any errors that might have occurred, and then we print a message, okay, done, regardless of whether it worked or not. Now that's stupid. Would you do that? No, that's just an example. And of course, finally is lowercase. If you've taken a scripting course with Python and you saw try and except, it's the same idea, except Python is a weakly typed language and you don't define what kind of exceptions you're going to be catching. In this one you do. Number format exception, well named because it's thrown when a number's format is inappropriate. Specifically, it's thrown by one of the parse methods. It should also be thrown, I believe, if you call .nextInt, but they type in a floating point number or a letter, words. Non-numeric strings, to be more precise. All right, this is assuming that we have a cool graphics library called line plot. Part of the swing library. That'd be cool. But, that'd be really kind of cool to do. But the swing libraries we do are going to be the ones that we develop using a Java, NetBeans form designer, rather than creating them by hand. However, when we're talking about it, maybe we'll make a set of code that we could copy and paste that'll actually generate the pages by hand, rather than using a form designer. Because the Java NetBeans form designer generates a lot of code, a lot of boilerplate code, and so it's kind of hard to, we need a simple example to look at as well as the complex stuff. So depending on the size of your try blocks is a bit of an art. Sometimes you use little teeny tiny try blocks. Sometimes you enclose large blocks of code in try. You just have to figure out what makes sense. Note that it's legal to surround an entire method body with a try block. But that's usually counterproductive because it makes it harder to identify the dangerous code, right? Something goes wrong and you don't know where it went wrong. You could put it, up at the top of main, try, and at the bottom of main, catch, exception star, catch absolutely everything. And then your program would never, the user would never see an exception thrown, but you wouldn't be handling them either. So if a chunk of code has several dangerous methods, adding a try catch for each call might result in cluttered code. Right, so if you do one thing that can throw an exception, immediately followed by another one, immediately followed by another one. Instead of doing try the first thing, catch it, try the second thing, catch it, try the third thing and catch it, especially if any one of those failures would cause the entire code to fail, just put a try and then do one thing, two, three things, and then close it and then catch errors for all three of them. So to improve program readability, you can consider using a single try block to surround the entire block of calls. There's something else that you can do besides trying and catching, which is that you can pass the buck with a throws clause. And so that's what we're going to do here. And we can define our own exceptions. You know, if we're defining a framework, you know, if you're writing like, you know, a 20-line program, are you going to be taking the time to define your own exceptions? No, but if you're writing a large project and you've developed a complicated class that can fail under certain circumstances, you may want to define your own exceptions that go along with that.
Would that be more practical than trying to search the entire Java doc for any possible exception you might have?
Yeah, I would think so. I mean, unless there's an exception that just happens to miraculously match what you're trying to write. A lot of exceptions, I mean, you know, if you're doing file I/O, the exceptions that it generates are fine, even if you just turn around and throw them, you know, yourself. But, you know, your stuff's going to be your stuff, and so you'll probably need to make your own exceptions to explain what it's doing. All right, so I'm just going to write a dummy little method here that could throw an exception. This is actually better illustrated with the try-catch stuff that actually throws no matter what. But let's do this. Public, static, double, and it's going to take two ints and divide one by the other. Int x, int y, but miraculously it's going to return a double. This is dumb, as always, but these division by zero ints are the easiest exceptions to write. So what we're going to do is we're going to do, you know, int result is equal to x divided by y, return result. In that case, why did I make it double? I could just make it int. And why did I not give it a name? Div. There we go. So public static int div. Why did I make it static? Because I'm invoking it from another static method. All class methods have to, if they're calling other things in the same class, the methods that they're calling better be class as well. Alrighty, so let's call our function, right? Int x is equal to division of, 4 divided by 0. And then we're going to print a message. System.out.println, done. So this code has no exception handling, so if it divides by 0, which it's going to do, it's going to generate an error. Not generate an error, it's going to show that an error occurred by doing an exception. So that is an uncaught exception. We could put the try catch right here, and it's probably the right thing to do, right? Try, blah, 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 just like we did last time. But I'm going to change it up a little. Instead of doing the try there, I'm going to say that this throws arithmetic exception. So let's add a little bit of code here. 2 print statements. System.out.println, leaving the div method, and then copy that and paste it above it so it says entering the div method. That way we can see if it worked or not. And what I mean by worked is how far through the method did it get. Okay, so I'm going to change this to valid data. Throws doesn't mean that it's got to have to throw that exception, it just means that it can. Alright, so when I run it, entering the div method, leaving the div method, done. So I passed in good data, so everything was hunky-dory. I'm going to change it to divide by 0. No longer is it going to be hunky-dory. When it runs, it generates an exception. I said run. All right, so divide by 0. And let's see if we can figure out the line that, how far it got. Entering the div method, right? But it didn't do anything else other than that. But we can put the try catch down here. Let's put another print statement, entering main, just so that we can see what's going on. And then we're going to try that code. Try the division. And we're going to try to catch the error that this guy throws, arithmetic exception. Arithmetic exception. I'm going to copy that rather than type it in again. Try that, catch, arithmetic exception EX, and let's just print a generic error message. System.out.println exception.get message. Would we do that for something that we were going to let the user see? No, we'd want to print out a better error message and whatever it's going to pass back, right? So when we run it, we see what happens. Entering main, entering the div method. It didn't get to leave the div method, right? We don't see our print message for, leaving the div method. But we do see that the error was handled. So rather than put a try catch inside the div method, we were able to make it so that we could put the try catch here. Would that have worked if we didn't have the throws up here? That thought just occurred to me. This is not pre-planned out of the lecture. Yeah, it did work. So did we have to add throws arithmetic exception? No. Typically, you don't put throws for unchecked exceptions. If you're defining your own exceptions, it's totally cool to go ahead and say, oh, by the way, this method might throw an exception, even if it's an unchecked exception, right? Because then when you're looking at the code and you're looking at that method, you realize, oh, there's an exception I might want to catch. For this case, we didn't have to put that there because it was an unchecked exception. And you remember, a couple of minutes ago I said that this would be better served by demonstrating with file IO. Well, we'll get back to that. But I want you to see this throws keyword. That tells the compiler that this method can throw that exception. So if it was a checked exception, meaning we had to handle it, this is one way of handling it. If this line of code generated a checked exception, we'd have to put the try and the catch there. Or we'd have to put the throws here and pass the buck. If we did that, though, if we put the throws and it's throwing a checked exception, then since we didn't handle it here, we have to handle it down here in the client. And we'll do that again with file IO. Make sure that it makes sense. Are we good, or do we need typo corrections? I'll scroll back up here. Here's our method. Pause, type it in, unpause. Here's the other one. And we can put a finally on here for whatever reason we would want to. Finally do this no matter what. System.out.println, whether it worked or not, we are done. And so we're going to see this finally. We're going to see this happen regardless of whether it works or not. And by work or not, I mean whether we catch the exception, whether an exception is generated. Okay, so a problem did occur, so it failed, but it printed out that message regardless. If we run it again, after correcting this so that we're not dividing by 0 anymore, we'll still see that finally message. So we left the div method, meaning that it did work. Whether worked or not, we are done. Now notice that exception handling kind of messes with the flow of control, right? Generally, your flow of control is that you're going to execute all the statements in sequence and then you're going to return. But when this exception was generated by that line, people in home can't see that. When that exception is generated, it doesn't get down to here. It doesn't get down to here. It doesn't return an end. It blasts back out of here and then goes down here to be handled or not. So, X in no way has a valid value if the exception is generated. Right? Because it didn't even get to that return statement. So, it kind of messes with your flow of control, just conceptually. Here's another way in which it could mess with your flow of control. What if you did handle the try-catch here? I'm going to make another method. We're not going to actually call it, but public static int div2 int x int y. This is just an example. I don't even care if you type it. Try this stuff, right? Int x is or int r is equal to x divided by y, return r. But if we get an exception, catch, I'm going to do the cheap thing and just catch the entire exception, all exceptions. I'm going to return -1. Right? That's stupid to do that if we get a 0. You know, it's a completely invalid value. But finally, maybe I will actually run this. But anyways, finally, system.out.println div2 sure did try. So what is it going to do? If this is fine, if this statement is fine here, it's immediately going to return, just like flow of control would make you expect. If it fails, it's going to jump down here, and it's going to return 0. But it's also got to do that finally, right? You know, that finally keyword means that this is going to happen no matter what. So it starts to return this, but nope, before I can return it, it jumps down here, it runs this line of code, then it comes back up here, and then it returns it. Isn't that weird? That C++ doesn't even offer a finally, as far as I recall, unless they've added it in one of the later versions of it. For just that reason. The flow of control is too weird, right? Because the catch, it starts doing this stuff, whatever was here, it would do that, it would do that, it would do that, and then as it returned, nope, right before it actually got to return that value, it would execute that line of code. Then it would jump back up and do that. So, no, it's blitzing our understanding of the normal execution, the normal sequential. So you just have to remember how it works. That's what finally does. What you do in the finally is you do cleanup that has to happen regardless of whether there was an error or not. Right? You had some files open, maybe you're going to close them there. So if an exception is thrown, the Java virtual machine immediately jumps out of the try block, starts looking for a matching call block, catch block. If there are statements in the try block after the exception throwing statement, they're skipped. The compiler is a pessimist. It knows that the statements inside a try block might be skipped. It assumes the worst. It assumes that all statements inside a try block get skipped. What does that mean? What if I did this? I'm going to take the return statements out of here. I'm going to modify this code. What if we had some variable up here, boolean OK, and we set OK equal to true right here. And then we try to print out boolean, that value down here. You know, if OK, print, great, it worked. System.out.println, yay, it worked. It's going to tell me that that's an uninitialized variable. Why? Because it's not sure whether that's going to execute or not. So the compiler assumes, for the purposes of checking for uninitialized variables, that that's not going to work. And we know that in our language here, if you try to use, you know, a variable that has not been initialized, it won't compile. Can we fix that? Yeah, if we do OK is equal to false here, the compiler is smart enough to go, well, what do you know? You did initialize that in both paths, so I'm sure that it's going to be initialized. Now that's a pretty smart compiler. Yeah, it's pretty smart that it can do that. That does have an impact on your programming, though. Not that we've talked about files, but if you had something like this, pretend that there is a data type called file with all caps, like there is in a C programming language. And then you do some stuff, and then you do some stuff down here, and then you try to close your file, right? Like that. Again, this is not valid Java, but it's conceptually, the same thing. And this was supposed to open the file. This won't work. Why? Because it was uninitialized, right? Or it thinks it might be uninitialized because this could fail. So you wind up writing dumb code like this. File F is equal to null. And then down here, you do if file is not equal to null, close the file, right? That takes care of the fact that this might not have been initialized. It also takes care of the idea that if that file wasn't open, then it's still set to null, and we won't try to do an operation on a null. Now, we haven't really talked about nulls much. A null is just an unassigned reference. If you create a reference and you don't give it a value, it's set to null. That's not strictly true. What if? Good enough. So if it's null, then it's not pointing to anything in memory, and you can't call any methods on it. So it would not allow that to compile. This is a way around it. You check to see if it's null. If it is null, then you don't try to call it. And when I said the compiler would not allow it, the compiler would be happy to compile it, actually. But you would get an exception if you tried to call a method of a null. We could see that real fast. Let me delete all this stuff with files, because like I said, that's not going to compile appropriately. But we've used scanners a lot, right? Scanner, sc is equal to new scanner, system dot, or even better, I'm going to have to add, an import no matter what. So if we have scanner is equal to new scanner, we add the import for it. What if we didn't have this and we still tried to use, dot next? What if we, initialized it to null, or it wound up being initialized to null, and we never then called an open on it? So then we try to do scanner.nextInt. That's going to blow up right there. That's going to generate an exception. It's going to give us a null pointer exception. Whatever. Null pointer sounds more like a C++ thing, so let's see what Java calls it. Exception in thread. Java returned 1. Well, yeah, it's calling it a null pointer exception. Even though the language doesn't support the specific data type pointer like C++ does, SC is in effect a pointer. It's a reference. We could almost call those things the same thing, but they're not. And when you if you create an object, but you don't actually create the object if it's got a null reference, and then you try to call one of the methods, the instance methods, you could still call class methods. If nextInt was a static method, that would not fail right there. I mean, it might not do what you want, but it would not fail because you can call class methods at any time, even without a created object. The compiler would warn you that, oh, by the way, you're calling a class method rather than an instance method. Why are you preceding it with the name of an instance? It would prefer for you to do it like that. All right, about time to stop talking about try-catch. Even though it looks like we haven't covered this chapter, we really have. Two types of exceptions, checked and unchecked. Checked exceptions have to be caught, or they have to be surrounded with try-catch mechanisms, or the code will not compile. How do you tell whether a particular exception is checked or unchecked? Check the API, or when you compile it, it's sure going to tell you, right? And that's really how people find out that it's a checked exception, when their code stops compiling. So, errors are unchecked exceptions. But then there are checked exceptions. This is odd that they have this hierarchy. But anyways, IO exception, which we're going to see a lot of soon, is a checked exception. And then IO exception has a lot of subclasses. You know, whatever kind of exception can happen with your files and your internet stuff. And then there are runtime exceptions, which are not checked. Number format, arithmetic. So here's some code that could generate, or that I'd rather just demonstrate that later with our file IO rather than making up something like that. So if you use a method or constructor from one of the API classes and you're not sure about it, just look it up. And you know how to look it up in the Java docs. You just type in the name of the class and then, you know, right click on it like a scanner. Well, I don't. Right click on it, show Java doc, and you'll see it. Or you Google it, right? That's really what most people do. If the method constructor can possibly throw a checked exception, you have to add a try-catch even to generate that object to construct it. Which is annoying, right? Because then you have to, like I was showing you with that file thing, if the scanner class could potentially generate an exception, a checked exception when you created it, you'd have to word it like this, right? You'd have to put the creation of it inside a try block. So you'd have to initialize it equal to null. You'd have to try it. You'd have to catch the problem that it can generate. It doesn't, so I'm not going to actually wind up catching anything. And then this becomes a real problem, right? Because you're probably going to want to use that scanner a lot. So it's annoying if you have code that if you try to call the constructor, it throws an exception. You just have to figure out how you're going to handle it. Are you going to handle it by, one thing you could do is just return out of your code as soon as you hit an error, right? That's one way to do it. Another is to throw your own exception and have it caught at the end of your client, you know, showing, which is effectively the same as returning out of it. It's a very common programming paradigm to write, if you're writing your own methods, you do as much error checking as you can at the beginning, and you do all your returning or your exception throwing right at the beginning. And then the rest of your code should be clean sailing. But you can't always structure your code like that. So if several statements within a try block can throw an exception, you could provide a generic catch block that handles every type of those, bad, or you provide a sequence of catch blocks with each catch block handling a different type of exception or group of exceptions. What does that mean? We've seen the idea of chaining multiple catch blocks, right? We caught the arithmetic error and we caught the divide by, the conversion error last week. So here's the generic catch that could catch, any exception. We don't want to do that. If I see you do that, I'm going to scold you. But you can also do it like, come on, give us an example. Stop showing us the generic exception handler. Like this. I want you to capture both the invalid path exception and no such file exceptions. That just saves you from having to, if both things are going to do the same thing, if both catch blocks are going to do the same thing, then this just lets you write one catch. That'll do the same thing for both of them, right? And then they followed up with a generic exception handler so that if it wasn't either one of these two errors, it would go ahead and do that. If multiple catch blocks are used, the first catch block that matches a type of exception is executed.
Because you could have multiple things that would catch the same exception, right? I mean, just in general. This will catch everything, right? But I'm going to delete this code here. We could do this. Catch exception EX. And do something, useful if that happens. An arithmetic exception is an exception, right? So these are both valid choices, but it's like, switch in case. The first case is the one that it jumps to, right? It doesn't jump to each one, it just jumps to the first one. So this would jump to that one, rather than jump, to the exception one. That does mean that if you arrange these out of order, it's not good news, right? If you think that it's going to jump to the arithmetic exception because it's more generic, less generic than that one, it's not. It's going to give you a compilation error because this would capture absolutely everything, and so any of the more specific exceptions would never be caught. And so that's what our error is over here. Arithmetic exception has already been caught. Sure has. What is it offering to do to fix it? Oh, it's offering to put it as a comment. Yeah, but that breaks the rest of our code. That's dumb. All right, so what am I going to do? I'm going to get rid of that exception EX. Or maybe I'll just put it down here. But I've already told you that that's poor form. You should only catch the exceptions that you think are going to be generated. Switch to files. Let's switch to file chapter. I don't think there's anything else in here that we need. So multiple catch block development. They're suggesting you could do the generic exception and then extend it, right? Every time you see it generate, an exception, you write that one down and you go and you add a catch for that one specifically. Yeah, okay. This is important, can't skip this one. Automatic cleanup using try catch, or try with. If you have a resource, do you remember that I said some constructors can generate exceptions? Here's the syntax for handling that. Try this. What that will do is it will create that object, it'll run this code, and regardless of whether an exception or not happens, then this will be deallocated. It'll be cleaned up, right? If it's got a close, close method on it, in order to close a file or whatever, that'll be handled automatically. So you don't have to specifically call file.close on it to get it to go away. Now, I don't think that in the examples I'm going to give you that I'm going to be taking advantage of that much. But I oughta, because it cleans up your code quite a bit. I already talked to you about how to handle, problems if it didn't get to create the object. How do you figure out whether you can close the file or not? And I was doing some monkey business with checking to see if it was null before I called .close on it. This would handle it, because if it needs to call .close on it, it would. If it didn't need to, it wouldn't. It does the proper cleanup. So if you do try and then parentheses, put a command there to create an object, then it handles the cleanup for it. And so that's the try with resource. So all classes that implement the closable interface also implement auto-closable. Now we've been talking about interfaces. If an object is auto-closable, it will close itself as soon as it falls out of scope, or when there are no more references to it. So we can tell the JVM to close it for us. Alrighty, I want to do some files. Got to do some files. So we're going to go to chapter about files. Please tell me that we have the PowerPoint for queued up. 16. All right, using files for input and output. Why do you save things to a file? So that you have a permanent record of it, right? You typed in your term paper and you didn't save your file. That'd be really annoying, right? So object output. This is actually skipping some of the ways of writing files that I want us to reference, which is using a print writer to write out a text file. A text file is different from the object output, which writes out entire objects. So does this cover print writers at all? Oddly it does, even though it wasn't up in the table of contents. Okay, so what we're going to do is we're going to write something that just lets us type in some lines of data, and whatever we type in gets saved to the file. So we're going to need a scanner, and we're going to need some code that implements a print writer. Let's just do it up at the top of our main. It's easier to find our code there. But we do need our scanner, so go ahead and create a scanner for Ernest. Scanner SC is equal to new scanner system.in. System.in. And now we're going to write some text to a file. So we're going to need to create a print writer, which is a way of printing text to a file, like typewriter, print writer. Print writer PW. I'm going to set print writer PW equal to null, just so that I'm assigning it something, and so I can go over here and do the add the import for java.io.printwriter. Or I could scroll up and add, import java.io.printwriter. All right, now I'm going to try to open. PW is equal to new mu print writer. Let's pass in a file name, output.txt. And it's underlining this. Unreported exception. File not found exception must be declared or declared to be thrown. Now we're not in a method that we've written, so we shouldn't add a throws clause. We could come up here and do throws file not found exception, right? If we were writing our own method, that would be a valid way of handling it. But doing that on main is really lousy. So we need a try catch to handle that error. Try this stuff. Catch. We have to specify what kind of error that can catch, or that can generate. I've already forgotten exactly what it does, so it's file not found exception. Let's give that a shot. Catch, type, file not found exception, EX. Cannot find symbol? Fine, add an import for it as well. Getting the idea that a lot of things are tucked away in java.io, and if we just added import java.io.star, we might get away without adding all these other imports. Okay. Now what does it mean, file not found? We're opening that thing for writing. How could that file not be found? Well, it'll call it not found even if it's a bad path, right? You're trying to open a file, on the D drive, and you don't have a D drive. If we do a Java doc on the print writer constructor, file not found exception. If the given string does not denote an existing writable regular file and a new file of that name cannot be created, and I love this part, it's so vague, or if some other error occurs. Yeah, okay. But anyways, alrighty. So instead of saying file not found, we're going to give a better error message. System.out.println could not open file. I'm going to try to be a slightly better programmer, and instead of just hardwiring this constant right here, I'm going to create a variable called file name. We could even ask the user for that file name. So, system.out.println, save data to what file? Question mark. Now let's read it in. String file name is equal to sc, not the word scanner like I was starting to type, sc.next line. And then here, printwriter, instead of new printwriter parentheses output.txt, let's open our file name. And that way, if we get an error, we can say could not open file, and we can specify the file name. That way the user goes, oh man, I put a percent sign in there and that must have broken it or whatever, without having to scroll their eyes back up. Never a bad idea to echo what they typed in, in an error message so that they can see what they might have done wrong. Alrighty then. Let's write something to that file. And I'm doing this in kind of the wrong way. I'm putting try-catches around every single command rather than putting a try-catch around the entire block. So we'll probably wind up restructuring this. Maybe to save time, I shouldn't do it this way. We'll put this code, we're going to move this code up into the try-catch block. But printwriter, yeah, I'm going to do that right here. I forget the step of doing it all. We're going to implement it correctly the first time to save time. pw dot print. You can print objects, you can print strings, booleans, chars, floats, longs. You can use printf, which is where you have a formatting string. It's just like the the other kind of print, system.out.print. So print, or heck, print line, is that going to work? I have created a file. And then let's close it. pw.close. Now it looks like the print line is not throwing its own separate exception. Let's go show Javadoc and see if it can throw an exception. The printwriter creation does. Does anything else other than constructor throw the exception? It certainly doesn't seem to be throwing a unchecked exception. No, doesn't seem to. All right, we're going to do this slightly differently now. We're going to create a file. Ew, I better make sure I get this exactly right because I'm going off the script here. The constructor for printwriter can also accept a file as well as a file name. It can also accept an output stream. And it is overloaded to accept a bunch of stuff. But the file class is of interest. So we're going to rewrite this just a little bit. Instead of doing new printwriter file name, we're going to do this. File, I guess lowercase file, is equal to new file, and we're going to pass in the file name there. Of course, we have to add the import for the file class. So add import for java.io.capital F file. And then when we do the printwriter, pass in file rather than the file name. Now why would we do that? Because the file class contains additional information that a printwriter is not privy to. Like what? Well, I'm going to type in pw dot, and I'm going to look at the methods. Not pw dot. I'm just trying to get information about the file. Check it out. Get absolute path. Get absolute file. Get canonical path. Get free space. Get the name of the file. Get the total space. Is it a directory? Is it a file? Is it hidden? Set whether it's readable or not. Set whether it's writable or not. There's all sorts of things you can do with a file handle that you can't do with a printwriter. So like maybe we're going to print out the entire path to the file. So let's add another print line statement. pw.println, and let's use our file reference to get, what's the difference between an absolute path and a canonical path? I'd have to Google it up to see. I'm going to go with absolute path. Get absolute file. Now let's run it. It should tell us the path to the file, which is of use, right? Okay, output.txt. I'm not seeing a save. Do my print line. Oh, because I saved the path to the file itself. That's kind of moronic. I'm sorry, guys. The second print line, make it print to the screen. System.out.println. And by the way, something we haven't used is system.error.println. If you do system.error.println, it prints it in a different color. Save to, I'm going to change it back to system, .out in a minute, but save dated what file? Output.txt. And here, check it out. It printed out the entire path to the file. That's useful information if you want to then turn around and open it in Notepad or something, right? Which I'm going to do. I want to see what's in that file. So I'm going to go and open this. I'm just pasting it into the start box and it pops it up. And since I had the .txt extension, it opened it up in Notepad. Now I'm going to just make this system.out.println. Okay. So, say I don't like having to remember. What if I'm worried, oh, I better close that file. Maybe I don't want to close that file. File.close like that. Oh, but what if I get here and I'm not closing the file? You could stick these things in as try with resource. So we could do that. We could cut those two lines and put them here instead. Try this business. Try these two lines of code. Variables in try with resources not supported in Java 1.8. The try with resources must either be a variable declaration or an expression denoting a reference. Okay, so it's wanting me not to do this. It's wanting me not to create the reference ahead of time. So I'm going to delete that. These are parentheses, not curly braces, although it looks like a block of code. Please tell me it's going to work. Incompatible types. Try with resources not applicable to variable type. File cannot be converted to auto-closable. Alrighty then, so a file is not an auto-closable device. So that was a bust. I'm going to undo all those changes. I apologize for that. I did not remember that you could not do that with a file. Okay, so I've undone it so that we have both our file handle and our printwriter reference there. Alrighty, let's make it slightly more useful than just printing I have created a file. Not that this is like the end-all be-all, but let's tell the user what to do. System.out.println. Enter some text or quit to stop. And then let's declare a string. S is equal to empty string. Now let's get our text. While S dot equals parentheses quit, end quote, in parentheses equals false. Now I should change it to, just using the exclamation mark. Excuse me, not equals to false. My brain is freezing. Is that right? Yeah, while it's not quit, I am going to go ahead and use the exclamation mark. I'm going to take out that not equals false. Show you how good programming techniques. I've rewritten it to while parentheses exclamation mark s dot equals quit. So while that's not true, we're going to get a line of data, system dot scanner.nextLine. And then we're going to write it out. pw.write that line of data plus a new line. So s plus quote \n end quote. Why? Well, you know, if we called it print line, it's a print writer after all, so I don't have to use write. I could use print. Let's do that. Print line, and then I won't have to, you know, add the new line. All right, so that'll work. We can type in as much as we want, and then when we type quit, it'll stop writing to that file. Save data to what file? All righty, output.txt. Enter some text. Hello, this is text. Quit. All righty, and so it opened that file, wrote to it, and closed it. So I'm going to copy that file path, go to the start block, or hit Windows R, paste that in there. Windows R launches the run box, and it created my file with the things that I typed in it. Hello, this is text quit. That is one way to save data, the print writer.
Can you show the get absolute file path?
Right there. Is that what you need?
Yeah.
Okay. So at this point, we've structured the code. We're assuming that if the print writer open succeeds, that nothing else in here is going to generate an exception, and it is going to get to close the print writer. What if that was not true? What if this code is riddled with stuff that could throw exceptions? We may never get to the print writer close. What if we want the print writer to be closed no matter what? Well, we should have created it in the try, you know, in the try with resource syntax, but we didn't get that to work. So what we're going to do is we're going to add a finally clause down here. Finally, after everything is done, if pw not equal to null, then close it. Whoops. pw.close. Close the print writer. You generally want to close your files as fast as possible. You don't want to leave that file open because the operating system may leave it locked and you can't move that directory or, you know, copy the file somewhere if it's still locked as being open. Okay. So this is the cheesy way of handling it. Why do I say that? Because if we could have handled it with the try with resource, that would have been better because we wouldn't have had to worry about adding this code to it. Why did I add the if print writer is equal to null? Because if this failed, if this call to the constructor failed, then we wouldn't be able to call .close on it. It would be a null pointer reference. Why did I set it to null in the first place? Because if I hadn't done that, then I'd be using an unreferenced variable down here, an uninitialized variable. So that is how I've found a good way to handle these things. Now, I'm not saying that that's the best. Whoops, why did I close that? Best way in the universe to handle it. But this seems to be a common design motif that I've seen elsewhere and that I do as well. Alrighty, so we've written out a file. What if you want to write out something more complex than just text? And there's multiple ways of doing that. There's all sorts of ways of printing files, not just a print writer. The print writer is specifically for text. And I never created a notepad file, but print writer is for writing text. If we have a few more minutes, it might be fun to enter the code that they've got here in this slide. Let's see if it looks like something we could accomplish quickly enough. Look at what they're doing is they're creating an HTML file. So they create a print writer. They get a file name. Once the file name is open, once they get a good file name, they print out some HTML code. They did a try with resources here. Now, do you have check out what they're doing here. They're using a scanner to read from a file rather than read from system.in. And we can do that. This will be the last thing we do. Let's go down here and assume that all of that stuff worked, that the printwriter worked, and now we're going to open that file for reading. Open the file for reading as a text file using the scanner. Okay. So scanner FSC, just on the, for now, I'm going to set it equal to null because it's going to be a file scanner. I'm pretty sure I'm going to have to enclose this stuff in try catches. But for now, file is equal to new file with our path, file name. It doesn't just have to be a file name, it could be a fully qualified path, right? C:\/ whatever. Now we're going to create our scanner. FSC is equal to new scanner system dot, nope, not system.in. We're passing in our file name. And that can generate an exception, so it's already starting to complain. So then, we just saw that we can use a try with resource to handle this thing. So let's give that a shot. Let's put the line try, and in parentheses, there, and then a catch underneath it. Now what exception is it throwing? Are you still giving me grief? I just typed in the code exactly like it looked on the slide. Did I not? No, they actually created the variable at the same time. Okay. We can give that a shot. Take this scanner line out, put it here. Try scanner FSC is equal to new scanner. All right, it's not complaining about that. But what it should be complaining about is that we're not catching the file not found exception error. Let me prove that to myself real fast. Don't do what I just did. I want to see the error definition. Yes, file not found exception. Okay, so that's what our code looks like, and our catch needs to be file not found exception. And again, it just needs to print out what it couldn't do. We could go and copy and paste to save time. System.out.println could not read or open to read from plus a file name. I forgot to give it a name. File not found exception space F or EX. EX is good enough for me. All right, great. We have a scanner. The scanner can do anything that we could do with text. Like a loop for reading. While fsc.has next line, as long as it has a line of data in it, let's read that line and print it to screen. Fs or string text is equal to fsc.nextLine. System.out.println, we just read, colon, end quote, plus that string we just read. Excuse me, text. So system.out.println, parentheses, quote, we just read, colon, end quote, plus text. We don't even have to close the file because since we did try with resource, it'll handle closing a file. So we don't have to do any of that monkey business about adding a finally clause to close the file. So that's our code. This will open the file that we just created for reading. And it will read every line of data that we've typed in. So let's do it. Save data to what file? Output.txt. It's opening it for not for appending. It's overriding it each time. We'd have to check to see if the printwriter class also supports opening for appending. Right now it's just blasting the last thing we save. Enter some text. Hello, this is some text. Isn't this so cool? Quit. And so then it opens it back up. We just read, hello, this is some text. Isn't it so cool? And it's even saving the word quit to our file. That wasn't my intention. We should have had some kind of if statement, right, to rule out writing that, you know, something like that. We probably could have used a while true with a break rather than what I just did. I don't feel like fixing it though. I know that you would know how to do that if you wanted to. Okay, so we have handled two kinds of text I/O operations. The print writer is for writing text. The scanner is for reading text. So you can do file F is equal to new file and give it a file name. And then you do print writer PW is equal to new print writer and pass in the file handle. And then you can do f.w print, you can do print line. There's all sorts of things that you might explore that it can do. There's also a write, and I'd be interested to see the difference between printing and writing. And then f.close. That's it in a nutshell, but you have to put it in the right framework. You must add the try catches or it won't compile. The exceptions are checked. To me, that's a silly term, checked exceptions, right? It should be mandatory exceptions or something like that. You just have to remember that. Okay, so that's opening it for writing text, and then to read a text. File F is equal to new file, parentheses file name. And then scanner FSC is equal to new scanner, passing in that file handle. And then you could read from it. String S is equal to FFC.getLine. Next line. Whatever kind of data you were looking for. And then FSC.close. All right. Hope that makes sense. I hope we know more about files than we did before, although I'm sure that in your Java 1 class you also did some file I/O. Next week's file I/O is going to be a little bit more interesting because we're going to do object files, which is where you can write out an entire object. Right? This is kind of annoying. We're having to write out, piece of data one at a time. What if we had a class that had 20 pieces of data in it? Right? It was a medical record. You wouldn't want to write something that necessarily, you might not want to write out all 20 of those pieces of data at a time. If you could write it out with a single call. And you can do that with object files rather than with, you wouldn't be using text files anyways, but there's more than one kind of binary file, and the object file is a cool way of getting it so that you can write out data from an entire object, and you could also read that entire object in with a single call. And for your project, that'd probably be pretty good because you're storing that data in an object, right?
Did you
From
make
your
one of those
form.
last semester?
Pardon me?
A video about that last
Yep,
semester?
yep. So let me find the video for that.
I think I know where it is.
Okay, yeah, you found all those files. Okay, alrighty. So let's make a Dropbox and call ourselves done. I haven't been checking. I've been trusting that y'all would flag me down if something wasn't working,
And when
but
you say an object, you mean like an array?
not an array, but an array list.
Array list.
You know what? An array is sort of an object, but
Well,
I've never
it's-
tried that. I've never tried that, but an array list, absolutely. And this is the chapter on it, so object file I/O, go to like page 10. You're going to want to look up object output streams. That's exactly what you need. They make that part of the PowerPoint so cool. Wow, I'm making an HTML file. They're just using it to write out any old data, you know. They're not explaining what an HTML file is. They're not opening it, you know. It's just, you know, it may have well have been, you know, the quick red fox, you know, chase the lazy dog or whatever. Element O, we are down to O. Alrighty. What was the other thing we talked about? Oh, exceptions. Yeah, we talked about exceptions a whole bunch. Alrighty. Looks like it's there. Go ahead and upload to O. See if we have any homework that's queued up appropriately. Looks like we have plenty of homework already waiting for you. So I think we ought to do one more lecture over files before I give you the file IO assignment. I guess I could post it and you could look at it if you're ahead, but not that many people are ahead. Alrighty, so I will see y'all soon.